asymptotic behavior of the function. So remember the first example that I did, I walked through the different cases where we did vertical asymptotes, and then there was the end behavior case. And so that's what we're going to get here is other asymptotes, and it has to do with the end behavior of the function as x is shooting off to infinity, as x is shooting off to negative infinity, the tails of my graph. There are two possibilities when you're looking at the end behavior for a rational function. Right? Either the rational function will approach some fixed value, right, approach a number like 0 or 2 or negative 5, as x gets bigger, as x gets smaller. Right? And if that's the case, then we have a horizontal, a flat line asymptote at that L value, whatever that number is. And a lot of times it's the x-axis, which is the line y equals 0. It's approaching the number 0. Not always. It can approach some number value, positive or negative, against that's what the tails are doing. Now, horizontal asymptotes are not strict. You can cross a horizontal asymptote. You usually don't cross it very much, and usually it's somewhere near the origin. But then once you get out to the tails, you don't cross it, you approach it. So as the x values get really, really big, in both the positive and the negative direction, I approach a specific y value. Right? And as I'm getting out to those tails, I actually never cross it, right, as I'm out the tails. Vertical asymptotes are always strict. They always are never crossed. Right? But there are, again, horizontal asymptotes can be crossed, and a second type of asymptote, which can happen with end behavior, is called oblique, or I like to use the word slant asymptotes. Slant or oblique asymptotes are also how the graph is behaving at the tails, meaning instead of approaching a single number, it's approaching a function value. And it approaches it. It actually never crosses. If it's a slant asymptote, it never crosses. The only asymptote you can cross is a horizontal asymptote. Vertical asymptotes and oblique or slant asymptotes are strict. All right, so I graphed some examples here. All right, so this first example has got horizontal and vertical asymptotes, and none of them are being crossed. All right, so those would be, actually let's highlight them. So these ones in yellow here, those are my vertical asymptotes. The green one here is my horizontal asymptote. Alright, so this is the horizontal. So that would be some y equals L, and at the tails, meaning as x is shooting off to infinity and negative infinity, my function, so as x is going off to infinity or as x is going off to negative infinity, my y values are approaching L. And they approach L. In this case, they don't ever cross it, right, in this first example. In the second example, I've got a horizontal asymptote, so again, it's this dotted line here is my horizontal asymptote. This would be the y equals L. As my x values shoot off to infinity, as my x values shoot off to negative infinity, my function approaches up. Now this one, I actually do cross it. The function actually crosses the y equals L. Right? One time, but then at the tails it doesn't. So you'll notice it just crosses it here near the origin, but then at the edges it doesn't. It approaches it on the edges. It approaches that number on the edges. Horizontal asymptotes, that's the horizontal asymptotes, the only one that can be crossed. Vertical asymptotes, which these are my vertical, you never cross. Oops. And then the last example is the slant or oblique. Again, I like to use the slant asymptote. So there's a line, and that's actually a vertical asymptote, and neither one of those can be crossed. So this is actually a vertical. This is my slant asymptote, which is a line. So y equals mx plus b. And so as my x values shoot off to infinity and negative infinity, my function shoots off to negative infinity and positive infinity, but as it's shooting off to positive and negative infinity, it's actually approaching this line. As x goes to infinity, as x goes to negative infinity, my y values approach the line, the slant line, the y equals mx plus v line. They don't actually ever cross. They never cross vertical or slant asymptotes. Right, Those are strict boundaries, edges. I approach the vertical line. I approach the slant asymptote, but I never ever cross it. The only asymptote that we can cross is the horizontal one. And again, typically it's towards the middle of the graph where, again, towards the origin. On the edges, I actually don't cross it. Right? So typically, not always, but typically. Alright, so those are my different types of asymptotes, and we'll get into how we find them in the next set.